Welcome to the Small Unmanned Aircraft Systems for Agriculture Risk and Reward webinar series. This webinar series is supported by four different faculty, starting with Dr. Mengmeng Gu at Texas A&M AgriLife, Rusty Rumley, staff attorney at the National Agricultural Law Center, Dr. Jo Marie Maha, remote sensor engineer at Clemson University, and Dr. Jim Robbins with the University of Arkansas System, Division of Agriculture. The purpose of this session is to provide an overview of applications in agriculture. This session is part 7 of a 7-part series. It is important to note that these webinars are partially supported by a grant from the Southern Extension Risk Management Education Center. Let's get started. Again, simply to mention that this is one webinar of the 7 webinar modules that are included in this series. The webinar team has developed several handouts that are available at the URL on your screen, or contact one of the presenters directly. Remember that there are lots of issues to discuss when dealing with SUAS, and this session will focus on how we anticipate SUAS will be used in agriculture. An obvious question is, why are we so excited about SUAS? The number one reason cited is the incredible image resolution provided by these low-flying and maneuverable aircraft. Other reasons that justify the enthusiasm behind SUAS are: 1, an as-needed basis. Certainly you can't simply fly aircraft under all conditions, but having access to an affordable platform that is fairly easy to operate has opened this technology up to many more potential users. Second reason is vertical takeoff for rotary platforms means greater flexibility within the flight situation. Number 3, the cost is a huge driver behind adoption of this technology. Similar imagery can be obtained using a standard aircraft, but the cost and availability limit their widespread use. Number 4, the availability of autonomous flight software makes application of this technology much easier. And 5th, and finally, these small automated systems lend themselves to the 3 Ds: dangerous, dirty, or dull situations. Imagine trying to inspect the glass roof on a greenhouse complex. It is certainly a safer solution to use a small drone than an employee walking between gutter-connected greenhouses. Everyone that has seen even standard RGB images leaves with the impression that SUAS can provide a new and amazing perspective to agricultural producers. Symptoms or issues not readily observed from the ground view are easily witnessed from low-altitude flights. So, if cost, access, etc. are the positives of this technology, what issues are we concerned about? Likely the 2 issues that we hope can be improved as the technology advances are payload capacity and flying time. How can we carry more and still fit under the SUAS limit and fly longer on the same power source? Is this the future of agriculture? Will farms in the near future use what are called swarms of SUAS to monitor production areas and then communicate with other ground or aerial systems to resolve an issue? Certainly, all of us are already aware of the many non-agriculture uses of SUAS, but how do we envision they will be used in agriculture? 2 disclosures before moving on to examples of agricultural applications. First, our expertise within the team really lies more on the plant side than the animal side of agriculture, so examples will reflect that. And we would like to recognize that many of these examples are thanks to a wonderful e-extension effort called UAS and Agriculture Learning Network, which is not currently active but produced some excellent material on UAS in agriculture. We have identified 5 key areas where SUAS can play a part in agriculture, and the first is monitoring plants and animals. On the plant monitoring side, this might be for nutrients, water status, or pests. On the animal side, drones will likely be used to monitor animal health. There's currently research underway investigating the use of SUAS to scout specific weeds or hotspots within fields. Mentioned in an earlier session was using SUAS to monitor for stress detection. It is likely that the most successful early impacts will be felt in crops with a closed canopy and a monoculture, such as turfgrass, soybeans, cotton, corn, sorghum, and rice. The second category of agricultural applications that we envision would include chemical or nutrient applications. Believe it or not, but there are many SUAS spray aircraft already on the market. It is important to note that the Yamaha RMAX, illustrated on the right of your screen, is used extensively in Japan and to a lesser degree in the US. However, the RMAX weighs nearly 150 pounds empty, so it does not fall under the small unmanned aircraft rules. It is important to note that no one envisions SUAS sprayers as replacing traditional aerial applicators. SUAS units have very limited payload capacity, so they will have limited use in applications such as small acreage specialty crops or to possibly apply shading paint onto greenhouses. One possible use for SUAS sprayers would be for vining crops such as melons and cucumbers, where application of chemicals is difficult once the vines close in. A third potential application for SUAS in agriculture would be for asset tracking and management. A good example is inspection of gutter-connected greenhouses. Currently, the method to do this is by workers walking the gutters, a very unsafe job. Inspection of center pivot irrigation and fencing would be other examples in this category. The fourth application is inventory of plants and animals. There is currently great interest in many areas of plant production to inventory plants during production. Here's one example from Kurt Nolte at the University of Arizona trying to inventory head lettuce to better predict future harvest yield. Dr. John Nowatzki at North Dakota State University demonstrating research to establish stand counts of corn. And researchers at the University of Florida estimating citrus tree canopy size to better forecast the orange yield. A concept that we have been investigating is to merge ground RFID tags with the drone. Included in this inventory application is use for crop insurance purposes. The ideal example for producers is to capture images before a hurricane and then, God forbid, after a hurricane. This visual documentation is something both growers and insurers are very interested in. Final category of application for SUAS would be used for marketing and sales. Any business that uses social media should have still or movie footage to help promote their business and products. We call this a low-hanging fruit as far as any application that can be adopted. In closing, we've just indicated 5 potential categories of applications, but maybe you have an application that we have not even begun to think about. Remember, SUAS is an emerging technology and exciting things lie ahead. An example that comes to mind is again work from the University of Arizona, where they attempted to replace the manual method of pollinating medjool date palm, but they used a drone instead. This concludes part 7 on agricultural applications. We hope this series helps reduce your risk in dealing with drones for agricultural applications.